Dear friends, we will be solving an interesting problem on Newton's laws of motion. This is a problem wherein there are three blocks. Okay, you see that this is block 1, block 2 and block 3. Three blocks have a mass of, this block is having a mass of 2 kgs, this mass is 5 kgs and this is 1 kg. All these blocks are connected to each other. They are connected to each other and that is the touch with each other, and it is given that there is a force of 12 Newton which is acting on this block which is of 2 kgs, and there is another force which is acting in the opposite direction which is of 8 Newton on 1 kg mass. So you are required to find the acceleration of each block, that is acceleration of 2 kg, 5 kg and 1 kg. This is asked. And second is you are required to find the net force on this 5 kg block. तर अशा पद्धतीचे प्रॉब्लेम्स जेव्हा येतात, then how do you solve them? Okay, so what we do is that in order to solve this solution, it is a very simple problem. What we do is that because these are connected with each other and you see that this force of 12 Newton is acting on this side and 8 Newton is acting on this side, so this will always be together. Okay, so this three, they would always be together and we can consider them as a single block. So let me consider this as a single block like this, let us say, or let me just draw it neatly. So we can consider this as a single block, okay, of mass 8 kg. Okay, so let us say this is 5 kg and then let us say this is 2 kg and this is 1 kg. Okay, so we can consider that this is sort of a common block, okay, somewhat like this. Okay, let us assume that this is the common block and the weight of this is, the mass of this is 8 kgs. Okay, and now I will draw the free body diagram for this. So this is 8 kgs. So this is an entire block and this is 12 newtons and this is 8 newtons. Okay, so what is the net force? So the net force on this mass of 8 kg mass is 12 newtons minus 8 Newton. And you would understand that because this is 12 and this is 8, the acceleration would be on this side. So this would be the acceleration, right? And because these three are connected, so the acceleration of 2 kg block, 5 kg block and 1 kg block would be the same. Okay, so 2 kg block would have an acceleration A, 5 kg block would have an acceleration A and 1 kg block would have an acceleration A. So 12 Newton minus 8 Newton, that is equal to 4 Newton. So the net force acting on this block, which is taken as a combination of 2 kg, 5 kg and 1 kg, that is 4 Newtons. And what is the mass? The mass is 8 kgs. Okay, so then applying the Newton's second law of motion, mass would be net force upon, acceleration would be, we are required to find acceleration. Okay, so acceleration would be net force upon mass. And what is that? Net force is 4 and mass 4 newtons and mass is 8 kgs. So Newton means it is 4 kg into meter per second square and 8 kgs. So this would cancel and hence your answer would be 0.5 meter per second square, which is the acceleration of this entire block, as well as acceleration of 2 kg block, which is the same as acceleration of 5 kg block, which is the same as the acceleration of 1 kg block. So this is the first answer. Okay. Now what is asked is, what is the net force on 5 kg block? Okay. So for finding the net force on a 5 kg block, so let me write down the net force on 5 kg block. I again use the Newton's law, second law of motion. So this mass is now 5 kgs. Acceleration on 5 kg block is, as we have calculated, it is 0.5 meter per second square. So this becomes 5 into 0.5, which is 2.5 kgs into meter per second square, which is nothing but 2.5 newtons. So this is the answer. So we have calculated both the things, that is, we have calculated the acceleration of each block. This acceleration is equal to this acceleration is equal to this acceleration, and this is we have calculated as 0.5 meter per second square, and we have also calculated the net force on this block, which we have obtained as 2.5 newtons. I hope you have understood this. Okay, so this is a very interesting problem, and this way we can solve this problem.